Hi, so in today's this video, I'll discuss how to solve the 2D questions and how to derive the equations for the 2D questions. So this will be suitable for everything like school level, IITJEE level, NEET level, it will be for everything. These are the very basics of 2D motion. So first of all, let me tell you whether it's a school course, it's the IITJEE or the NEET. The physics overall is not at all tough. Physics is not tough. The only thing is that when you start a topic, you should focus upon the basics. If those basics are clear, it's all very much related. What you call derivation. Derivation is nothing else than the general solution of a problem. In derivation, ultimately what we do, we start from a basic concept. And through that basic concept, we proceed on. We keep on calculating, we do some mathematical parts, we involve some other law in between, then we do some other mathematical work, and ultimately we reach to a general conclusion. That general conclusion, you call that what? You call it a formula. Okay, that is a formula. What the conclusion has come, usually you call that is a formula. So you see, we will start from the very basic point, what is a 2D motion, and in this video, I'll reach up to some of the complicated questions also. So you see, 2D motion, or you also call it motion on a plane. Motion on a plane. Those who are very new, like have recently come in the 11th class, even they can also understand it very well. It will be from the very basics. So you see, motion on a plane. So first of all, how you will recognize that this is a 2D problem? The recognition is like what? Recognition is like in the question you have, its initial velocity and acceleration, they are along two different lines. The particle starts from this point, its initial velocity say along this direction A, and suppose acceleration is along this direction. So initial velocity and acceleration, they are not initial velocity and acceleration, they are not along one line. They are along two different lines. So you will tackle it like what? It will be motion on a plane. Like see in the 1D motion, that is on a straight line motion, what happens? Initial velocity and acceleration, they are along the same line. Acceleration might be in the opposite direction also, but that will be in the line of initial velocity, then the motion was on a straight path. And that was a 1D motion. Now see here, the initial velocity is on a different line, acceleration is along a different line. So we will say that it's a 2D motion, and in all such cases, the path of the particle will always be what? It will always be curved path. The particle, the conclusion is the moment you get that initial velocity and acceleration, they are not along one line, you can immediately conclude that the motion will be along a curved path. Now as I told you, physics is what? We have some scientific fact, we have some discovered fact, we have some fundamental law. First of all, to understand that law, then to apply that law in the different kind of physical situations. So like I concluded, the motion will be along a curved path. In certain application of those laws in certain physical situations, this is done through what? Through some mathematical equations. So you see, I have written the conclusion, but we'll reach up to this conclusion that yes, how the motion is on a curved path. There will come a mathematical result. That result will show that yes, its path is what? It's curved. Right? So this is the recognition. Now see, after the recognition, when you recognize, this is the first step. Second step is what? Consider any two mutually perpendicular directions. और वो कोई भी दो हो सकती हैं, ठीक है ना? कोई भी दो mutually perpendicular directions. Like suppose you take one x direction, the other y direction. You know, one is what? X direction, and the other is what? Y direction. But still see in most of the cases what happens, if it is the motion on ground, generally we take what? Horizontal direction is the x direction and vertical direction is the y direction. If it is on an incline, suppose it's on an inclined plane, this is the inclined plane which is fixed on the earth. Now we throw the particle like this it will follow a path and will reach somewhere here. In this case, when this is on an incline, we take that along the line of plane, in the direction of plane, this x direction and y direction is this. Though it is not a law, the law is only this, means to solve it, the law is only this, that you consider two mutually perpendicular directions. But this I'm telling you, in most of the cases, like in the 99.9% cases, what we do, if it is a motion on the ground, we take horizontal direction as the x direction and vertical direction as the y direction. And if it is on a plane, we take along the direction of plane is the x direction and perpendicular to that is what? Y direction. Uske jo perpendicular hoga, that is what? Y direction. In most of the cases we do that, but in this case also sometime we have to change it. Sometime we consider a different direction to be the x direction, but in the very rare cases, which when the need comes, that will be told. Now see. Now look at this. We consider two perpendicular directions. The initial velocity was at an angle theta from the ground. That was given to you. That will be given in the question. Now what is the next thing? So after you have considered the two mutually perpendicular directions, the next step is what? So recognition, then perpendicular directions, and after the perpendicular directions, third is what? You will see here that out of the initial velocity and acceleration, which is the parameter which is neither along x direction nor along y direction. There are only two parameters. One is the initial velocity and the other is the acceleration. So out of these two parameters, which is the parameter which is neither along the x direction nor along the y direction, so it is u. So parameter which is neither along x nor along y, resolve that into components. So here we resolve the u, it becomes u cos theta, and along this direction becomes what? U sin theta. So third step becomes what? Resolution into components. Resolution into components. And when you resolve into components, you have to keep in mind, like here only u was neither along x nor along y, so that has been resolved. If the same thing had been true with the acceleration also, then in that case, the acceleration would also have been divided into the two components along x and along y. So, and even like say, if both the parameters, initial velocity and acceleration, suppose one is along x direction and the other is along y direction, then there is no need of resolving. So you have selected the x and y direction, then you saw which is the parameter out of these two, which is neither along x nor along y, that parameter will be resolved into components. Now see, you have resolved into components. Now why we have resolved into mutually perpendicular components, let me tell you the basic of that. That is the concept. That is the main concept. It is what? Suppose you have a vector r, then you know its component in a direction making an angle theta from it is r cos theta, and in the direction perpendicular to it is what? R sin theta. Perpendicular to it is what? R sin theta. Right? Along this direction it is r cos theta, and along this direction it is what? R sin theta. So if I have vector r and its component in the direction making an angle 90 degree from it, means here the theta becomes what? 90 degree. I will have r cos 90. So because this is r cos 90 and this will become r sin 90, perpendicular to this becomes what? R sin 90. R sin 90 becomes what? R, and r cos 90 becomes what? 0. ये आ रहा है ना, ये देखो. So r cos 90 becomes 0 and r sin 90 is r. And this is logical also. How logical? Because see, if r sin 90 itself becomes r, then the other component should be 0. Because if one component itself is the complete vector r, then the other component should be obviously 0. But this is the main thing, that a vector does not contribute in its perpendicular directions. A vector does not contribute in its perpendicular direction. There is no component of this vector in the perpendicular direction. Is that clear? So means what ki, what happens here, like see, if we have the vectors, like suppose here we have velocity vector along this direction u cos theta and its component along this direction u sin theta. Now suppose I want to apply some law of physics for the x direction. I want to apply some law of physics for the x direction. Law means the equations that we conclude. Basically, the law of physics is what? Law of physics is the relation between different kind of physical parameters. Like Ohm's law, V equals to IR, the relation between V, I and R. So the equations that we conclude, generally they are the laws, they come in the they come in the form of what? They come in the form of equations. So here see, suppose I want to apply some equation for this direction. I want to apply for this direction. Is that clear? If I want to apply, suppose this law B equals to U plus 80 for X direction, this becomes a law or this becomes an equation. So when I apply the equation for this direction, I need not to worry about these parameters. Like see, when I keep the value of U here, U sine theta, and there is no acceleration in this direction, you see acceleration G is along this direction, and you already know that if the component of G along this direction will be what? It will be 0 because it is at 90 degree. If there had been a component along this direction, we would have already resolved it. So there is no acceleration along this direction, we'll keep it what? 0. So V becomes what? It becomes 0. So the main thing is what? That when I apply the equation for this direction, though the initial velocity and acceleration is present in the perpendicular direction, but they are not contributing or they are not interfering along this direction. Neither they contribute nor interfere along this direction. That is the main thing. As I told you, a vector does not contribute to its perpendicular direction. कोई भी vector अपने से 90 degree पे contribute नहीं करेगा या interfere नहीं करेगा. So while these parameters are present here, you can use any equation like a straight line motion for this direction and conclude any parameter. Like I got the velocity V, so this is not the overall velocity V. You will say what? This is the velocity of X direction after time t. It is only for X direction, so there is a velocity of X direction. And because see what is happening in the X direction, simultaneously the things are happening in the Y direction. So the time that you will calculate, like see if I take that the time of motion for the X direction is t, the same time t will be used for the calculation of Y direction also. Because see if the particle goes like this, suppose it goes like this. Now at any point of time it is here. So up to time t, its displacement of Y direction is this, and displacement of X direction is what? This. That means in what time t, it covered this much of displacement along the X direction. In the same time, it covered this much of displacement along what? Y direction. So that means what? The time parameter will be same for the calculation along the two directions, but the initial velocity, acceleration, etc., these parameters are along the X direction as well as they are along the Y direction. Is that clear? They are along the X direction or they are along what? They are along the Y direction. Do you understand this? This point is clear. So this Vx equals to U sine theta. What was the initial velocity? The same is the velocity after time t. Now see, I discuss it further. So after you have resolved into components, then the one 2D problem is resolved into what? Two 1D problems. Means what? Whatever information you want, you cannot directly calculate. Like suppose you have to calculate the velocity. What is the velocity after time t? After time t, what is the velocity? You cannot directly find what is the net velocity after time t, but you can calculate what will be velocity after time t in the X direction. Separately, you can calculate what will be the velocity in the Y direction after time t. Then when you get to know the velocity in the X direction after time t and the velocity in the Y direction after time t, then you can combine them. Is the resultant of the two vectors is what? Is square root of a square plus b square plus twice of ab into cos of theta. There are two vectors. Magnitude of one vector is a, magnitude of other vector is b. An angle between the two vectors is what? Theta. Then the resultant of the two vectors is this. So when you get the velocity after time t in the X direction, and also you get velocity in the Y direction after time t, you can combine them. Like one vector becomes velocity Vx, the other becomes what? Vy. Like see, this is Vx. You see, just we calculated Vx, similarly we applied Vy is equal to Uy plus Ay into t. Everything of Y direction, nothing of X direction, only the time parameter is common. So Vy after time t becomes what? U sine theta minus what? G, because this is in the opposite direction. So as for like our convention, like here I'm taking what? If I'm keeping its value positive along the upward direction, then the downward direction parameter will be what? Negative, so minus gt. This is the velocity Vy. Now here in this formula, we'll keep what? In place of Vx, in place of A, we'll keep u sine theta. In place of B, we'll keep this parameter. And angle between this parameter and this parameter, this A and this B, is what? 90 degree. So cos 90 will be 0. That will be the net velocity V. That will be the net velocity. And what will be its direction? That will also be calculated from the same formula of the resultant. If resultant makes an angle alpha with the direction of A, then tan alpha will be equal to what? B sine theta upon what? A cos, upon what? A plus B cos of theta. So in this case, the angle between A and B is what? 90 degree. So sine 90 becomes 1, cos 90 becomes 0. So this becomes what? B by A. So here in this case, like you had to calculate velocity after time t, and t is this time to reach here. At this point, its velocity is along this direction, say v dash. So you will get the value of v dash. V dash equals to square of this plus square of this. Remaining part becomes 0, and that velocity makes an angle alpha with the direction of A. A is what? Vx. This velocity makes an angle alpha with the direction of A, that is x direction. Then tan alpha will be equal to what? You see from here, is theta is 90 degree here, so that becomes B upon A. B upon A means what? This parameter upon this parameter, this parameter. Is that it? This parameter, this is not A, A is this. This is A. So this parameter upon this parameter, that will be the angle that this velocity will make after time t from the x direction. Is that clear? So basically, see, whole thing was what? That first of all you recognized, then you took two mutually perpendicular directions, then you saw which vector is such, which velocity or expression is such, which is neither along x or nor y. You resolve into components. Then what has been asked, like velocity is asked to be calculated after time t. You cannot calculate directly the overall velocity. What you can calculate, what will be velocity of x direction after time t, what will be velocity of y direction after time t. Okay, na? And then you can combine the two vectors to get the overall velocity. Like I told you, then the v dash will be equal to what? Keep the value of vx and vy here as a and b. You'll get the value of what? The overall velocity. You can also get its direction by this formula. Tan alpha equals what? B by a. Here why it becomes b by a? Because in this case, angle between vx and vy is 90 degree. So this becomes 90 degree. So that is why it becomes what? B by a. Is that clear? So this is a basic thing if you understand it. So whatever be the parameter, I calculated velocity. You can also calculate what? You can also calculate the displacement after time t. So that means after this step, the fourth step becomes what? Applying the suitable equations of 1D motion for x or y direction. Whatever information you seek, so for that certain equation you'll have to apply for the x or for the y, and time parameter in the two will be what? Same. Like say we calculated velocity. These are the steps. Say you had to calculate displacement after time t. Displacement after time t. You know it very well that in all the equations of motion, when we write the equations of motion like v equals to u plus at, s equals to ut plus half t square, etc. In all the equations, s is for displacement, not for distance. S is for what? Displacement, not for distance. So here see, we want the displacement after time t. For the x direction, we can write sx is equal to ux into t plus half ax into t square. Now see sx here, ux is what? U sine theta into what? T, because you have to calculate after time t, and x is what? 0, so this becomes 0. Now similarly for the sy, this is what? U sine theta, so everything of y direction, so this is what? U sine theta into t. Now in the y direction, acceleration is opposite to the velocity, so we write it minus of half into gt square. You got the value of sx and sy, then the resultant we will calculate. These are also vector quantities. The angle between them is what? 90 degree. So this term will become 0. We'll keep in place of a, we'll keep sx. In place of b, we'll keep what? in place of B, we'll keep this, we'll get the resultant displacement. And you can also find its angle, that what is the direction of resultant displacement from the initial position. So that angle, say, suppose will be alpha. This was, initially it was thrown in that direction, it was following a curved path. Now see, that angle is alpha, tan alpha will be equal to what? Sy upon Sx. So to calculate all these things become very simple. Now see, this is how to apply key equation along the x direction, how along y direction, then to combine them to get the overall parameter. But see, when we derive the same things for the school exams or in competitions, the only things that asked are not these, what will be velocity after time t, what will be displacement after time t. Rather, they ask something else. And there you have to apply the common sense that for this thing, in one equation, you'll have to use in one question, you'll have to use the equation for the x direction as well as for the y direction. So in that, you'll have to do what? You'll have to use the common sense that for which direction, which equation has to be applied. Like, look at this. Suppose in the same case, when velocity, initial velocity u is at an angle theta, acceleration g is downwards. Now, say we have to find the total time of flight. Time in reaching from this point to this point, we have to find the total time of flight. Now see, as I told you, there's the x direction, there's the y direction, only u is in between, so u cos theta, and write u sin theta here. Now see, up to this point, like see, you can use the coordinate system. There's the 0, 0, there's x, there's y, and here x coordinate is not known, suppose x, and y coordinate is what? 0. So through this, you got to know that in reaching from this point to this point, the displacement of y direction is what? 0. In reaching from this point to this point, displacement of y direction is what? 0. So you see, s equals to ut plus half it can be applied for what? For the y direction. We apply for what? Y direction. Now we keep s because it is for displacement. So in reaching from this point to this point, displacement of y direction is what? 0. So s is 0. Initial velocity of y direction is what? U sin theta into what? T. Acceleration is in the opposite direction, so that is minus half of gt square. This term it transferred to this side, half gt square becomes u sin theta into t, and t will be cancelled, so you get t equals to u 2u sin theta upon what? G. You call it a derivation for the school exams, that there's what? Total time of flight. But see, it was not about derivation. As I told you, derivations are only the general solutions. The same thing could have been asked in the form of numerical also. So if it matches, this motion is called projectile motion, and if it matches with the standard projectile motion, you can directly use the formula for solving a problem, solving a numerical. But if it is not exactly matching it, suppose the motion starts from this point, in that case, the basic method to see that it's 2D, to take perpendicular directions, to resolve into components, then what you need, accordingly use the equation along x direction or along y direction, the suitable equation. So now see, because see, this is the total time of flight t. Now suppose they ask, what is this range, this distance, displacement along x direction is called what? This is called range. So now see, you have to calculate that, what is this range r. Now see, range is the displacement of what direction? X direction. So this r, what I say, x coordinate. We apply s equals to ut plus half at square. इसमें इंक डालिए, इसमें चलेंगे s equals to ut plus half, इसमें s equals to ut plus half at square for the x direction. So now see, when you apply it for the x direction, it becomes what? S becomes r, which you have to calculate. U becomes what? U cos theta into t. As I told you, it will be the same time. In this time it reaches here. So time t is what? 2u sin theta upon g. And there is no acceleration. So half at square term becomes 0. Now you have u square by g. And 2 sin theta into cos theta is what? Sin 2 theta. So this becomes the range r. This is the range r of this motion. So means calculating the parameters is not that simple. That is not that tough. It's usually very easy. You have to follow the basic part, and after the basic part, whatever has been asked, you have to apply equation for the x or for the y and you can solve it. ठीक है ना? Now see, I take up one question which students sometimes feel that these kind of questions are tough, but I feel that they are simply based upon this basic only. What I told you, they are based only upon this basic. Like see what basic? Suppose we have an incline of angle alpha, and from the incline at an angle beta, we throw a stone with a velocity u. From the incline, we throw the stone with a velocity at an angle beta with a velocity u on the incline. Obviously, it will follow this path. Now see, as I told you in the beginning, when the motion is on an incline, what you have to do? Consider x direction along the incline and y direction perpendicular to the incline. Now your x becomes what? Along the incline, and y becomes perpendicular to the incline. Initial velocity is along this direction and acceleration due to gravity. That is what? Vertically downwards. Now as I told you, you will have to resolve the initial velocity and acceleration along the x direction and y direction if they are not along x and y direction. So now see here, this u is not along x direction because our x is this, y is this. So this component becomes what? U cos beta. And along this direction becomes what? U sin beta. Now see, this angle is alpha, so this will be 90 minus alpha, so this will be alpha. So component of g along the y direction becomes what? G cos alpha, and component along x direction becomes g sin alpha. You know, it becomes g cos alpha, and this becomes what? G sin alpha. So this step has been done. Like what? Taking two perpendicular directions, then resolving the parameters along x and y direction, it has been done. Now, the next point that I had told you in the last question also, immediately mark the coordinates. This is what? 0, 0. From where the motion starts, whether it's this question or any other question, from where the motion starts, mark it 0, 0. This is the x coordinate 0, as well as the y coordinate 0. This is the 0. I write the coordinate here, coordinate of this point. This is what? Coordinate of this point is what? 0, 0. And coordinate of this point is what? Suppose this is a range R. So x coordinate will be the range R, which we will have to calculate. It is not known. And y coordinate is what? 0, because this point lies on what? X axis. Immediately that got cleared that y coordinate was 0 in the beginning and y coordinate is 0 at this point also. That means what? Up to time t, displacement of y direction is what? 0. So we apply s equals to ut plus half at square for the y direction. We apply it for the y direction. So you see, the displacement of y direction is 0. Initial velocity of y direction, I take that this direction is positive and this negative. Initial velocity of y direction is what? U sin beta into t. Acceleration is in the opposite direction, so that is what? Minus half of gt square. Acceleration is along the y direction in the negative direction, so that is what? Minus of half of gt square. So this term is transferred to this side, half gt square equals to u sin beta into t. One t will be cancelled here. So see, this is wrong. It's not g. It's what? Acceleration along y direction is what? G cos alpha. So I should write here what? G cos alpha into t square. We have to take the only y component of acceleration, that is what? G cos alpha, and because it is in the direction opposite to the direction of velocity, so that will be taken as what? Negative. Now so this into half g cos alpha into t square. T and t will be cancelled, so we get that t equals to twice of u sine of beta upon what? G cos of alpha. This is the time t. So there is a total time of flight, capital T, the time to reach up to this point. Now say we have to calculate range also. How much is the range along the incline? So range is what? Displacement of x direction. That means what we'll do, we'll apply the equation s is equal to ut plus half at square for the x direction. For the x direction, so range r will become what? R becomes this initial velocity of this direction. We take that this direction is positive and opposite of it is what? Negative. It's our assumption that we are taking like that, and we are free, like if we want to choose this direction positive, this negative, we can do that. But generally, because in this case the motion is involved only along this direction, so it's better that if we use that, this direction is what? Positive. So it becomes u, this is what? U cos beta. This is what? U cos beta into t. T will be this value. So I'm not keeping here, the expression will become bigger. This value of t will be kept here. Now acceleration is in the opposite direction. How much? G sine alpha, because you will take all the things of x direction. So minus half G sine of alpha into t square. So this value of t will be kept here, and then it will be simplified and you get what range are. So means ki the basic concept, the again and again, the same thing is used, whether it's a school exam question, it's a derivation or anything else. The same thing has to be done. Now see, these are the standard derivations even used in the school examinations also, though in the school examinations they use the motion on inclined plane less, but you found that it is not tough. When that was on the ground, the x was chosen as the horizontal direction, y was selected as the y direction, but in this case one is along this direction, other is along this direction, but we had to do almost the same thing. What we did for the ground, what we did when it was on the ground, almost we did the same thing here also. The only thing is that in the beginning, those who start, who just start the 11th class, so initially they feel that the resolution into components and all, the gradually figure becomes complicated. But see, when we resolved each and every parameter, that was easy. This was u cos beta, u sin beta, similar, because you had taken that this x and this y, similarly g. This alpha, 90 minus alpha, alpha, so this becomes g cos alpha, this becomes g sin alpha. Then the direction for which you are applying the equation, बस आप जिस डायरेक्शन के लिए इक्वेशन लगा रहे हो, आपको केवल उस डायरेक्शन के पैरामीटर्स लेने, you get the results. Time parameter, what you get from the calculation of one direction, you can use the same time for the other direction also. ठीक है? Now see, these are the standard derivations also, but suppose it's not the derivation, right? Like it's some question say. Like for example, they tell you that, okay. Okay, so in this, because see, I wanted to introduce the 2D motion and how to tackle it. So in this video, I'm ending it here, though I could not start that complicated part due to the, as I wanted to only this much in the first, this video. So in my next video, maybe after 1 or 2 days, I'll continue this part to make that clear that even the toughest questions of the 2D motion of any level, they could be tackled with the same basic philosophy that I gave you, and I'll let you know how. I'll give you the examples. Okay, all right. Have a nice day.